Hey everyone, here's the hemodynamic loop that we looked at this morning in class, and I've got a lot of this initialed already, so perhaps that'll help kind of give you a cue as to what the names of everything is. So just make sure that you are aware of what the names are throughout the hemodynamic loop, and make sure that you spell it correctly. That's always important. But we'll start over here in the left heart. We've got the left side of the heart on this side of our loop. The LA would be the left atrium, which pumps blood into the LV, which is the left ventricle. The left ventricle receives its blood from the atrium. The ventricle is responsible for moving blood throughout the rest of the circulatory loop, so it's got a much major role than the atrium does. The atrium, when it ejects its blood into the left ventricle, has to open this set of valves, which is the bicuspid or the mitral valve. As you'll remember, the left ventricle has to contract and move blood into the aorta, so we need to go ahead and put that name here. And so the aorta will help you remember the valve that lies closest to it, which is the aortic valve. Okay? From the aorta, the blood continues in a clockwise pattern on this hemodynamic loop down to the arteries, from the arteries to the arterioles. From the arterioles, we begin perfusing the vascular bed of the systemic system. So these are the tissues we talked about this morning: the brain, our legs, arms, feet, hands, our organs, our kidneys, heart. Everything is perfused here in the body, allowing the oxygen to be extracted from the blood, and then as the byproduct of metabolism, remember, CO2 is produced and put back into the blood as a waste. The blood continues traveling to the venules, to the veins. These coalesce and merge and become larger until we're in the inferior vena cava, or from the upper torso, from the superior vena cava. The blood merges, and we refer to that as the central venous pressure. And we're going to talk about our pressures throughout the loop next. Here at the right atria, which contracts and pushes blood through this tricuspid valve, the TV, into the right ventricle. And I'd asked a question this morning about the differences between the tricuspid valve and the bicuspid valve. Why do we have a 2-leaflet valve on the left heart when we have a 3-leaflet valve on the right heart? It's just something to think about. It's kind of interesting. The right ventricle contracts, pushes blood into the pulmonary artery. So again, the pulmonary artery, the valve system closest to it, is named after the pulmonary artery. It's the pulmonic valve. Okay, so just very important to remember your valve systems. From the pulmonary artery, we then begin perfusing blood through the pulmonary capillary bed throughout the pulmonary system, which moves the blood back into the pulmonary vein after gas exchange has taken place. Remember, oxygen diffuses into the blood and carbon dioxide diffuses out. That blood that is now reoxygenated moves from the pulmonary vein into the left atria, where we begin the loop again.